first three values in sorted order, in the descending order. Three values as a contender for answer. All right. Now for 0, 1, 2, keep a track of all the numbers which, when taken modulo with 3, gives 0, 1, and 2. All right. And sort them again. Choose the very first element, that is the largest elements from all these three scenarios. All right. And choose that as a contender again. Similarly for 1, 1, 1. Uh, Keep a track of all the numbers that gives modulo 1 with 3 and choose the largest three values. Similarly for 2. And among all these contenders, the value that gives us the maximum sum, that will be our answer. Okay. And that is what we will return. So let's move to the implementation part. This was all about the logical part. So how can we implement this? Let's move forward. So what do we need? We need to keep track of all values that gives modulo x. What do x mean? 0, 1, or 2 with 3. Alright. So what is the value of x? It can be 0, 1, or 2. So we are maintaining a vector of size 3. Let's name it as track or vec, let's say. Alright. For keeping a track. Now iterate all the numbers. While iterating over all the numbers, check if the current value modulo with 3, what it gives. If it gives 1, 0, or 2, that is the value of x, and insert this number in that index of vec. Alright, so vec of 0 gives us track of all numbers that give modulo 0 with 3. Alright. Similarly, vec of x gives track of all numbers that gives modulo x with 3. Now just push this particular element inside the vector. Now what do we need it? We need to sort in descending order. All the three vectors or track arrays we have created. To sort in descending order, just use reverse begin. Alright, R begin. Now we need to do the same thing for the vector with modulo 0, modulo 1, and modulo 2. Alright, this is it. Now create an answer value. What does this answer say? Answer gives us the maximum among all the contenders. Alright. Now iterate over all the possible contenders. The first contender was 0, 0, 0. So if vec at 0 dot size is greater than equal to 3, because we need at least 3 elements to have a scenario of 0, 0, 0. Alright. Then answer is max of answer comma vec at 0, 0 plus vec at 0, 1 plus vec at 0, 2. Alright. Now the second scenario. In the second scenario, we have 1, 0, 1, 1, and 1, 2. So every vector 0, 1, and 2 should have at least one elements. If all of them have at least one element, answer is max of vec at 0, 0 plus vec at 1, 0. We are picking up the largest element from all these three tracks. All right. Now the fourth scenario, we had 111. Okay, third scenario we had 111, and fourth scenario we had 222. Just copy paste the first scenario we had. We were checking for 0. Now we are checking for 1, 1 0, 1 1, and 1 2. That is the largest element of track 1, the second largest element of track 1, and the third largest element of track 1. Similarly, the largest element of track 2, second largest element of track 2, and third largest value of track 2. Alright. Among them, the maximum answer, that maximum contender is maintained inside the answer value, answer variable. So return that answer variable. And that is it for this problem. Now let's move forward to the third problem of today's contest. So in this problem, we were given okay, okay. So let's move to the third problem statement now. The third problem says is that we are given a integer array nums of length n and a binary string of same size. All right. Initially, our score is 0, and each index I where s at I is equal to 1, that is the string contains one value at that particular index, contributes num I to the score, that is the index 1 in this particular string. Let me zoom in. In this particular string, the index 2 is having value 1. So the corresponding index in nums, that is index 1, which has value 1, will contribute uh, that much value to the score. Now we have some operations that we can apply. We can swap two characters if the string at some index is 0 and the next index is 1. Alright, if we get this scenario. I think the whiteboard is not working. Okay, it is fine. So what do the problem say? Problem say that let's say we have this string. Now we need to find substring of size 2, which is 0 1. Now we can swap these two indices, that is 0 1 can be converted to 1 0. Alright, so note down some observation with this operation. What do we observe from this? If the left index is 0 and the right index is 1, then a operation can be performed, and this 1 can be shifted one leftward. Alright, but is there a possible scenario in which a particular 1 value can move to its right? I don't think so. No. because there is no particular scenario in which left is the smaller index, that is 1 is the smaller index and the operation can be performed. So value 1 can only move leftwards. This is the observation, first observation. Okay, now apart from this, is there any constraint on the string, final string to be formed? So for this, let's try to have a construction. If we can uh, come up to a construction where this particular scenario is satisfied, that is, in the final construction, all the final ones are present to the leftward of their initial value, then we can say that all the possible values which satisfies this particular constraint can be uh, framed with this operation. Let's say our initial string was 0, 0, 0, 0, 0, 1, 0, something like this, and we want how many number of ones are there? 1, 2, 3, 4, 5. So we have 5 ones here. So what is happening? This one is shifted here, this one is shifted here, this one is shifted here, and these two ones are shifted here. Is such a construction possible? I would say yes, it is. And firstly, check that if it follows the first constraint. Yes, all the ones, final indices of ones are present to the left of their initial value. So this particular constraint is satisfied. Now, how can we frame this string from this string? Just start with the very first one. After one operation, it will be shifted one index